Hi, my name is Wandri Jooste, and my supervisor is Andrew A, and I'm based in Dublin City University. My research is focused on developing more efficient neural machine translation models. These models are used to build tools like Google Translate or Microsoft Translator, for example. And the amount of data used for training a neural machine translation model is growing, and that's to increase the accuracy of the translations output by these models. But this in turn also increases the training time that is needed to train a neural machine translation model. And often the accuracy is only marginally increased, but the data used to train a model is increased significantly. For a lot of science labs, it's easier to participate in making labs green. As you can clearly see the difference things like waste disposal in terms of recycling makes, and also sustainable procurement of materials used, and so on. However, in computing, we don't always see the amount of electricity we're using, especially when we're training models on GPUs. Like a car, for example, you can see, especially in old cars, the emissions coming out of the exhaust, but you won't necessarily see the emissions coming out of data centers or things like that. And if you have a look at the table there, just as an example, for the average car for its whole lifetime, it emits about 126,000 pounds of carbon dioxide. And for a neural machine translation model, this can go up to 620,000 pounds of carbon dioxide that's emitted by training one neural machine translation model. And that's the main reason why I'm focusing on making these models more efficient, because neural machine translation needs to be more sustainable. And I aim to do this through developing a more efficient and effective knowledge distillation framework, where knowledge distillation is a model compression method. And you transfer knowledge from a big teacher model to a smaller student model. And more specifically, I'm looking into the kind of knowledge that needs to be transferred or distilled. And this will hopefully help make neural machine translation more sustainable. Thanks.